All right, question number 10. We want to determine which of these statements are correct. So we have the limit as x goes to 4 of 1 over x minus 4 squared. We have that does not exist. We have that is equal to infinity. And then we have is equal to negative infinity. And we are told to select all that apply. So which of these are correct? So we're going to write limit as x goes to 4 of 1 over x minus 4 squared. Okay, so what this looks like is the it's close to the rational function. It's, I guess, the rational function squared, I guess we could say. Let me go back to our course and go to our graphs and videos and kind of point out. So if you are familiar with your parent functions, let's go to the basic one. This graph, the rational inverse squared. Okay, so if we look at the rational squared, we have both ends going up at 0. So as we approach 0, both ends are shooting up to positive infinity. So this equation is kind of like that. X minus 4 squared, except it has a transformation. So if we think about that and think about what the graph looks like, that means instead of being centered at 0, this graph is going to get shifted 4 units to the right. 1, 2, 3, 4. And this will be my asymptote. Even if you do that at the bottom, you set the bottom equal to 0, you'll get an asymptote here. Vertical line, the graph doesn't cross. So I know that this graph is going to be like hugging the x-axis at 0 and then shooting up as we get closer and closer to 4 from both sides. Just using properties of transformations. All right, so this is the graph that we would get. So looking at this, as we approach from the left, we shoot up to positive infinity. As we approach it from the right, we shoot up to positive infinity. So even though infinity isn't a number, we would say that the limit does not exist. So DNE, it does not exist. But we also say that it goes to infinity. So both of these things are true, but since they both go the same direction, we can say that it goes to positive infinity. Now you can also do this numerically. If you did not know what the graph looked like, you would just want to approach 4 from the left and from the right. And so thinking about approaching 4 from the left hand side, that means I would start at 3 and I would get closer and closer to 4, so I would get bigger. So I would say 3, 3.5, 3.9, and then you can just keep going 3.99 and just go as close as you can to 4 and see what the pattern is. Well, if I look at what's happening, I'm plugging in these values for x and I'm going to be subtracting 4. So if I subtract 4 from each of these, you'll see that we're getting closer and closer to the number 4. We're approaching 4. So here we will get a negative 1. Here we will get a negative 0.5. And we will get a negative 0.1. And then a negative 0.01. And when I plug those in here and you square them, they will come out positive. So I have a large number. Well, 1 is relatively small, but when you compare 1 to the smaller and smaller values that are getting squared and becoming even smaller, this number will be relatively big compared to something on the bottom being small going to 0. So this whole thing will be going toward infinity from the left. Now if I approach it from the right, so I'll start something bigger than 4 and come down. So let's say 5, and then we'll go to 4.5 because we're going to get closer to 4.5, sorry, and then say 4.1, and then 4.01, and so forth and so on. We're just getting closer from the other direction. And again, we're subtracting 4. Okay, what we will be getting, positive 1, positive 0.5, positive 0.1, positive 0.01. So you're getting the same exact values because we picked those numbers in such a way that we're just getting closer to 4 on either side. And again, you're going to be squaring them, so you got a positive and a positive. You're shooting off to positive infinity, same thing that you would notice from the graph. So the answer choice that we would want to say here, the ones that apply are B, the limit does not exist because infinity is not something that we ever reach. However, since both sides, left and right, go to positive infinity, we can also say that the limit is going toward positive infinity. We can say where it's going, but it also does not exist.